Welcome to another episode of Everything Intellectual Property. Today, we have a very special guest with us. This gentleman has invented an AI method to detect pneumonia in chest x-rays that has up to a 99% accuracy rate. By the way, he also is a high school senior. Please help me welcome Prithvi Krishnan. How's it going?
It's going good. Thanks for having me.
Oh, definitely. And I was going to say, I appreciate you giving me a little bit of time this morning to kind of go through your journey and your process, which is unique, I can to say the least, especially with you being a high school senior and really just kind of going into your high school senior year and kind of doing all the things that you are doing and still being able to invent and just kind of have this, just really understanding this knowledge of artificial intelligence. I was just telling you offline how just me as a patent attorney, I kind of even want to brush up on my skills as it relates to AI. But you just kind of being a high school senior or just kind of high school student and kind of being really proficient at it. I always like to kind of, before we get off into things, just kind of really break down or for you to describe what it is that you have done as it relates to your invention.
Mm-hmm. So for what I've done with, what I've done with the invention or what I've done
just describing the invention. And it's kind of interesting because typically the people I've had up until this point on the podcast, they typically have like a physical invention, whereas like an apparatus or whatever the case may be that they got patented and they're selling or whatnot. But yours is different in the sense that it's not necessarily a physical thing, but it's more so a method for doing something. So can you just kind of describe to the audience what it is that you have invented as it relates to AI, the method of detecting pneumonia in these chest x-rays, just so the audience, as we're getting off into it, they have an understanding of what you have created or invented?
Absolutely. So my pneumonia detector, it is through image processing and object detection, which is taking chest x-ray images and looking for different patterns throughout the each of the images to decide if the person whose chest x-ray that is has pneumonia or not. Though that is the process of actually detecting pneumonia through that software. And so my process of doing it was originally my grandfather, he passed away last year. And so that was my motivation to actually look at, okay, so what could we have done earlier to detect pneumonia? Because we only detected it a week after he actually got it, and that could have saved so much time, one in money, and just how much time we had with him. Maybe he could still be here right now. And so that was the overall process that I was thinking of. And so when I was thinking about it, I was thinking, okay, so how can I expand this? And so I use these online software. So Google has its own coding software.
Okay. Well, did you know anything about like AI? Sorry to interrupt, but did you know anything about AI before kind of you started to kind of go down this path of going on Google and coding and whatnot, or did you, have no knowledge at all about it going into this?
So I had a little bit of knowledge. I have my nonprofit that I run. That was running a couple months before that. And had still been running. So I knew enough to get started, but I still had to learn what are more libraries that I can use. So one of the main things of novelty, because people have done this before, it's not as high of an accuracy. I tried to make sure mine was the most novel version out there. And so my 3 ways of doing it mainly were using through AI. There are things called models. And so these are the things that pretty much the chest x-rays are running through on the software. And so I use 3 different models, which is the most that I could find more than anyone else used online. As well, I was using 2 different data sets. And so, which I'll go into further detail later in the podcast, where using those different data sets of like 5,000 data points, 2,000 data points, right? It's a lot of data. It's a lot of data that you need, because to get a high enough accuracy, which a lot of other people didn't get, is because they weren't using a high enough amount of data. And so that really hurts them with how to actually see the feasibility and the actual applicability of all the work that's being used.
Okay. And then and start even backing up a little bit. Is it a way that you can, like, what was the conventional? How did people do this conventional? I know you talked about it briefly as far as the conventional methods not being as high of an accuracy rate in terms of detecting pneumonia. Is it a way that you can explain, okay, what were those conventional methods of, trying to detect pneumonia, say, such as, and sorry to hear about the passing of your grandfather, but in terms of those methods to even kind of detect his pneumonia, that you said it was kind of really kind of too late in that process when they found out that he had pneumonia?
Yes. So conventional methods right now are more on actual like physical things. So the doctor will look at the image and they will be looking just by hand and by some pen or something. They'll be like circling what the areas of like opacity. So in the image, there will be like dark spots and there will be like dark areas. And there'll be clear signs of, okay, where the pneumonia is. Usually it's pretty easy to tell. That's why like doctors most of the time will get it right or get really close. But the problem is that they don't know really where it started in the actual image. So if you look at the image, right, where in the lung did it actually start? It's very hard to tell with this process because for them, they're looking at, okay, so where just is the general area, right? And then they're trying to just pinpoint by like guesses, just trying to see. But like my software, which I try to make novel. So mine, after you actually run the software, it will show an arrow to the actual like spot where the pneumonia actually originates in the image. And so that's where I differ from the conventional methods that are more physical now.
Okay, no, nice. And then you talked a little bit about the goal with it's, your method is to reduce these false positives and increase the true positive and false negatives. Can you maybe talk about the importance of that aspect of it? Because I do think that it's really important to be able to say, hey, you have it, and knowing that you have it, as opposed to saying you have it and you really don't have it, or saying you don't have it and you really have it.
Yeah. So two aspects come to this. So the true positive and the false positive, false negative. Obviously, you want more true positives and true negatives coming out of the software because that shows that, okay, that this one, it's working. It is, we're actually seeing, a real diagnosis or a real, that you're just fine compared to the other ones. And also, so the metrics that I used, so like precision, recall, F1 score, all these different things are just metrics to see how well my software did. And so all of these metrics are made up of true positive and false positive rates. And so the formula for it is where you're just taking true positive and false positive rates divided by the total amount of positivity rates. And you're trying to see, because one, you obviously want to make sure no one wants pneumonia, but if you're going to have it, you want to make sure that you're actually that you actually do have it. And so that's why, like, for all those metrics, being able to see a higher, like a 99% or 98% precision score, just higher than anyone else is on the market right now.
And what's the I guess the market accuracy rate? If you can maybe share that with the list.
85% on a low end, 90% on a high end.
Okay, gotcha.
That range. And so that's where mine comes at a difference, because all the precision scores, all the accuracies, everything is on a 98 to 99% scoring range for me. And I can go into more detail if later about how that actually happens or about why. And so my research, my main goal overall was to make sure that pneumonia detection is more efficient and less handheld, more automated. And I achieved that specifically through this software, as the result was 270 images, which this was the highest amount of like iterations that it worked best on. So 270 chest x-ray images in 70 seconds, 98.81% accuracy. So comparatively to 10 images of my grandfather, that took multiple days. Yeah. And so that's where I'm trying to like step in and be like, okay, how can I help this space?
Got you. So then a couple things here. So I know you talked about, I think it was a week before. Did your grandfather have it a week, and then he maybe, I mean, once it was detected, it was a week before he passed? Did you say that was?
So it was, he started having symptoms. So what I meant by a week was, so 3 weeks he was in the ICU, and then before that, for 1 week, he had symptoms on the on the first day, we took him to the doctor, and then they took a week to get everything set up. Before that, he had symptoms. It was like he had a cold like recently before that. So as we were suspecting another cold, and we didn't really do anything with it, and it passed 4 days later. So our thought was to wait 4 days, give him medicine, do all those things, and then didn't stop. And so he just felt really miserable. And so we went to the doctor. They did a diagnosis, they took x-rays, and then they would say, okay, we'll give it to you in a few days. Week passed, they finally diagnosed, we sent to the ICU. And that's where I was kind of annoyed, because it's like, take 1 whole week to just do a couple x-ray images. I understand that you have a lot of other patients.
Yep.
But there has to be some way that you can automate this to make this quicker, where I could spend more time with my grandfather and not be like thinking, hey, like, what does he have it? Does he not? Because I can't actually be near him because of that. So then that's
right. Okay, so you're saying that, okay, this thing, once he got the x-rays, it took pretty much a week or so before the x-rays, the results came back then.
Mm-hmm.
As opposed, it seems like your invention would have kind of spotted it immediately, or more or less immediately.
Yes, 100%. So like I said, mine takes 70 seconds to do 270 images. Yeah. And as I said, 270 was the best performing one. The lowest performing one I had was like just like near 98%. Or not just near 97%. And okay. So it's still very high comparatively to every other part. Yeah. So it was just like baffling me to see like a hospital with so much tech, so much like resources, more than me, and not be able to solve this issue without someone else having to do it.
No, for sure. No, I definitely understand that. And can you talk a little bit about, because we're going to get off into that, the deep learning algorithm, and we're all going to have to buckle up as you kind of explain that, because I know it can get a little bit more on the tech side, which I think it's important and necessary so that the audience can try to understand a little bit better about AI, but then how, again, you don't always have to create a physical product. You can have a method kind of using AI and different things and still get that protected and build a business off of it. But you talk about the importance, I think, in one of your previous interviews, you talked about, 2.5 million people die every year off pneumonia. So this is like a big issue. Well,
yes.
Were you still there though? Okay. So was that?
Yes. 2.5 million people die every single year of.
I'm not sure if I'm not sure if the camera is kind of freezing up there.
Okay. Is it working now?
Okay, yeah, but it seems like it's working better now. So I'm sorry, what were you saying now about the?
Okay. Oh yes. So 2.5 million people die every single year of pneumonia worldwide. 50,000 people around that die every single year in the U.S. of pneumonia. And one thing about that I want to note is that I have a question for you. Have you seen on the news pneumonia? Like, do you see pneumonia on the news? Like, you see, okay, COVID, you see like the viruses and everything, but do you see pneumonia like actively?
No, I mean, and again, that's an interesting question, and I think it's a smart question. Hey, look, at to answer your question directly, no, I haven't, and but I guess maybe on the other side of things, I don't necessarily watch the news just because I think it's more of a kind of targeted, like what they want, they're going to give you what they want you to have, whether that's, COVID and those different things that they want to kind of try to, I don't want to say scare you, but try to push out those narratives out as opposed to something that is killing way more people and has been doing so for so long and, still don't say anything about it. I just think it's interesting. But yeah, to answer your question, no, I haven't kind of seen that or the news or just kind of the medical area talk about pneumonia and trying to help out that number or reduce that number of 2.5 million people dying every year.
So that's actually what I wanted to hear, because what my point is that in the last few years, there have been so many different viruses. There's been COVID. The flu is very rampant every single year. There have been different viruses. There have been different types of flus in the last decade. And so all of these things, right, get so much media attention. Pneumonia, very little media attention. Very little, awareness to the general public of, okay, what is pneumonia doing? Like, they'll brush by it, but then they don't touch on it that much. And that was one of the goals I had with this is I don't want people getting pneumonia as much, so that maybe that could stop the awareness, but also that's not happening right now. And so my goal was to see, okay, how can I bring awareness to this very fatal disease, but also be able to save it, and so or save people with it. And so that was really interesting to me, because I was doing research and I was looking, and I saw pneumonia was very rarely mentioned on the news. Right. When you look at different health or science news channels, they'd be more focused on the bigger ones that more people care about. Because if you go into really nitty gritty diseases, no one's going to watch. And so that's in their mind what they're doing. But also it's still, pneumonia is not some small level disease. It kills 2.5 million people every single year. It's been there longer than COVID. It's been there since the 1800s, since president passed away of pneumonia. So wow, that's the thing. So it's that was just, I wanted to just touch on how my project it's not just for solving it and just identifying it, so also bring awareness to, okay, this global disease.
No, yeah, and that's cool, and I definitely appreciate you doing that. Yeah, I mean, it's interesting in terms of what the news is, I guess, purporting and kind of putting out there. I'm not sure what their rhyme and reason is, but it's almost unfortunately, or maybe fortunately, that they're kind of taking a hit as it relates to their credibility over the years, as far as kind of just focusing on these stories that, in the grand scheme of things, is kind of little relevant, and there's other things that they can focus on that are, I guess, bigger issues in society as a whole. So then, I guess maybe now trying to tackle, I guess, your particular algorithm, and again, I'm not sure how kind of you want to start with it. I know it has that CNN and convolutional neural networks, and kind of talking about the kind of that process and the different layers or whatnot. You kind of explain a little bit more detail as far as how your AI method works.
Okay, so like I was saying before, so I'll just talk about the main just normal architecture. So you take an image, right? Any input image of a chest X-ray, and so it can be any size, and I'll explain that later. So you take the image, and so like I said, you have 3 different models that it passes through. In mine were called GoogleNet, ResNet, and DenseNet. And so there are specific numbers at the end of them. And so at these 3 models, I chose one because they had the best accuracy on past research individually, and they had the best applicability for higher, a little bit of higher amounts of data points. And so you take these 3 models, and so the image will pass through these little components of each model. So each model will have the 3 parts of the convolutional neural network. So you have which is just a deep learning algorithm which is big for like identifying patterns and features in images. So that was really applicable to me. And so each model will have a pooling layer. And so the pooling layer is where the image, like I was saying before, you don't need a specific like image size, because the image will get cut down to only the important features and the important areas that are actually show where the pneumonia is during the pooling layer. The fully connected layers, where you're taking the final product of the other two layers and actually identifying the patterns and the features now. And then the final layer is the I forgot the name of it. It is pretty much a layer. I'll stay with the features of it anyway. It is pretty much a layer that now identifies instead of just cutting down the image and identifying the features, it will identify now, okay, where are the different areas that could be plausible to pneumonia. And then those are the 3 different steps for each of the models. Then finally, once you go through all of those steps, you're seeing the performance metrics. So like I said before, I took 4 different performance metrics in accuracy. So I did precision, recall, F1 score, and AUC. All of these 4 metrics are made up of what we were talking about earlier, the true positive and the false positive rates, which is in their formula. And so after each of the models are tested on these 4 different metrics, there are things called weights that are made because of that. So using a formula called, this is kind of a little bit technical, it's called a hyperbolic tangent. It's a very weird math thing. So it's like, so using that, it's a set formula. So using that formula, the weights are computed for each of the models. Okay. So based on how well it did for all the 4 different metrics, weights are computed, which are pretty much like different, they're like different aspects and different like specific features of the actual image. And then once that is completed, based on those weights and based on all the metrics, it will decide if this image has pneumonia or not. So that's just a broad description.
Okay. And then this is, I guess, going to be, the next part of it, or the more interesting part of it. I'm assuming that you do have some type of patent for your method. How was that process to the extent that you do with, saying, hey, going to see a patent attorney and then kind of explaining to him this, and then obviously they're trying to draft an application so that it's going to get over the hump. Like you said, there's other methods out there, but this is a novel one and it's non-obvious. And I'm not sure. I would imagine that he kind of went over those details, but exactly. I guess how was that process to say, okay, now I need to protect the invention? Because again, it is costs and things like that associated with protecting your invention. Then just kind of being in high school is, I guess, whether you're in high school or not, a lot of people who are adults don't kind of really understand the patent process. But being in high school, I would imagine, adds another level of complexity to it. So you talk a little bit about kind of that process and, okay, I have this thing. And this thing actually essentially helps detect pneumonia and checks x-rays better than everything that's out there at this point. But now I need to protect this thing. So I guess what was your thought process or your next action? Did you know about patents? Did you not know about patents? What was that next step for you in terms of trying to get this thing protected?
So this will be, yes, for use, because you are a patent attorney, you'll understand pretty much everything I'm saying. So yes, I did go through a patent attorney. He explained all the different parts. So first, as you know, you have to go through a prior art search. Prior art search is where you are looking
or even
at...
I'm sorry, stepping back, did you know of a patent attorney? Did you just Google?
I forgot to answer that. Yes. So before all of this, it was more of a dream originally that I was going to get a patent on this. I have heard It was like because originally I thought it was just a really hard process, and like it was a lot. Okay, I would have to do so much research and all these things. And actually, I got the idea. It's kind of funny. I was watching something on TV from like something like I was watching years ago, and then like just popped up. It's called the show called Stuck in the Middle. It was on Disney. Yeah. And so this girl, she had a patent for an idea of like some like dry clean or something. And then I was listening to that. I was like, maybe if she could do it, I could do it. So I was like that was a little delusional at the time, but it actually like came to fruition when I did have to start researching, on the U.S. Patent and Trademark Office. One, are there like pro bono like patent attorneys just to see are they applicable? But like you have to be, if you do want to get a patent and you are listening to this, you have to make sure you understand what like area of finances you're in, because they have like the micro entities, the small entities, and then the like larger entities. Yep. And so for me, because I specifically don't really make that much money, I'm a micro entity, but for someone who's making $150,000 every year, they'll be probably a small or a larger entity depending on that. So that's what I was like researching. And then getting back to the process, right? I actually found a patent attorney who was cheaper than what I saw online from most other ones. Okay. And so I was able to go through, the prior art search, right? So looking at these prior arts that could be similar, and I was looking for the non-obvious component. So is there a non-obvious improvement that anyone who knows how to code couldn't do? Is there that novelty component where it's different from in some aspect? Is there is there actually an invention here? And I forgot the last component, but the 4 overall components, these are the steps that you take in the prior art search to see, is your invention applicable to actually getting a patent? And then finally, once you get through that prior art search,
did you do that on your own, or did you have, because typically it kind of...
The attorney, yes.
Okay, the attorney would do it, and then he'd provide you the results. But I know, and there's some clients I have that they at least do a beginning search, and then I'll maybe supplement their search if they're trying to reduce costs. So it seems like the attorney, in this case, did the search and then brought the results back to you.
I did, actually, speaking about that, I just went on Google Scholar, and I was just looking at, because they have patents on there, and so I was just searching up different patents there. I just went to USPTO, just did a brief search, because I just wanted to do it on my own also. I couldn't see anything, so that was a good sign at the start. And then once I was able to do that, then, like you were saying, a lot of this process, as I learned, was a lot more through the attorney than I actually thought. And so, like, going through the next step of, so you're writing a first draft of your, I believe this is the next step, the first draft of the claims. And so you're writing, so what are you claiming is patentable, right? Is it the system? Is it the method? Because for me, it was the system and the method. Correct. So some people do this just for like my area. So is it like the method? Is it a physical product that has tech? So those types of things. And so after you've, and then you do also 4 figures. So like all this architecture that I'm talking about is just from an actual image that I made, in an actual architecture image, which you have to diagram. Well. What did you say?
Like a block diagram.
Yes, exactly. Just 100% block diagram. And so you're taking those figures and you take the actual claims and then you make it all finally into a specification. So you have so now this is where you're actually specifying the entire process. So you start out, are you publicizing this anywhere? So journals, conferences, are you doing those things? And then you go through the actual process of the whole invention. So what are you doing? Like, what were the steps? Pretty much every single thing. How does it work? Just going through everything. And then the advantages, the disadvantages. So it's a long process, but it did help me learn a lot about, like, one, it made me feel like an adult. Just at the start, it's just like seeing all that, because I've seen like so many, like in college, like when I go, a lot of people get patents in college. So for me, being able to go in high school and like being able to like look at universities and be like, hey, I've done research that can help your university in the future as well. And so like overall, it was just a very just amazing experience. And I'm guessing you had that experience when you help others get patents and when you got your own first patent.
No, right. And to be honest, I haven't gotten my first patent yet, but just helping others get their patents. And then, hey, you as a patent attorney, it feels a little better when you helping like that startup company get it, as opposed to say a company on the Fortune 500, which they have a ton of patents in their portfolio. But to that person who has a startup and they got the first patent, which is going to really kind of help them, now they can get investments and things like that for their business. It just kind of feels a little better, or feels a little bit more, I guess, noble helping that person out, because it just means more to them. It means more to them compared to kind of the big company, which is almost like they get their patent, they're throwing in their vault of patents and whatnot.
It's just protection at that point. But you said, startups, they need these patents because these bigger companies, since they have so many patents, they could just like do so much. But if you have a patent, you have something for those startups that gives them a level of protection that they need to make the step forward. It's like a need. It's not a maybe. And like, maybe I do this, then I can step forward. No, you have to do it. So then they're actually able to compete with these like bigger market people who are just like with a billion different patents that they just don't even care about at the end of the day.
And then even just to even get funding, I know a lot of investors, they'll turn away if you don't have your invention protected via patent. So that helps out as well. So then you kind of go through that process. It seems like the patent attorney, you kind of draft the application, the claims, the detailed description, or the specification is what you called it. And now you have, at least you filed a patent application. And as we all know, this stuff, federal government, this stuff doesn't take, it isn't a quick process. So typically it's going to take maybe a couple years. And then you have this process of office actions being issued, and your attorney.
I actually have one thing to say about that real quick before you continue. I wanted to publicize this. There is a program now. If you are a micro entity, I believe it's only for micro entities. There is what is called a first time flyer program, where it is, and that's what I qualified under, where you get your patent in 2 to 3 months compared.
So it's like an expedited filing, examination process. Wow, that's good information.
Program. It just came out. Like they were on, they were doing trials last year, and then it came out this year. So my attorney came to me, and this is what, if anyone does want to get a patent, you should do this program. And if you qualify, it just is so much better, because now I'm gonna get my actual like approval probably in like a month, or like a month and a half.
Okay, so you're still
I'm pending. Yeah, right now I got through all the process, but I'm just waiting now, because we've applied, we've done everything. So, but like I was saying, if you can do the first time file program, do it, because it will spend way less time, and you'll be able to get, if you have like a startup you want to get like started in a couple months and you need a patent on it, and you don't want to wait the 1 to 3 years, you do this program, you'll get it done way before your startup.
I like that. No, I appreciate you mentioning that to the audience. I do think it'll benefit them. So then, okay, you're pending at this point in time. What is the goal with things? Again, I know you have this nonprofit. You are doing a ton of things. I know we were talking about it offline, which is kind of crazy that in high school, going into your high school senior year, Eagle Scout, Taekwondo instructor, math instructor, you're doing a ton of things. What is the goal with, because a lot of people, as they're adults, hey, when you get to be an adult, more times than not, you're not doing something just for your health or doing for the sake of doing it. You're trying to extract money out this thing so that you can kind of live and hopefully live a comfortable lifestyle for you and your family. But for you, don't necessarily have those, I guess, requirements of having to pay bills. Hopefully, you don't have to pay bills and things like that. Are you kind of looking to kind of create a business off of it? Maybe I know you're doing a nonprofit with some other things. This going to be a nonprofit type thing, or are you going to license the product? Like, what's the overall goals once you get the IP for the actual company?
Oh yes. So my goal right now is it's just is awareness because like just at this moment. But once I get the patent, my right now, because it is kind of hard for me just to start a big just startup on my own, right? I'm talking to universities. That's my number one goal. I've talked to already, or I've like reached out to a few universities, and they said just wait until your patent and then we can continue. And so that's like the main goal as of now, because that's the probably the the most applicable patent like step. What were you saying?
No, I was going to say, it seems like things have froze up a little bit again, but I think you're good now.
Okay, yeah. So the next step for me, because I can't do a startup immediately, and once I get into college, very good chance I want to make a startup out of this, because I want to be able to spread the awareness with an actual invention that works and works very well, compared to other inventions that probably don't work as well, but they're still selling it because it's still high enough. And so like universities like UT Austin, UTD, Rice University, all of these great universities in Texas, they're very good universities and they have like millions in research every single year. And so being able to like work with them, maybe sell it to them, license it to them, something along those lines would be my best next step for me.
Nice. Now, have you figured out? I know going into the high school senior. I'm not sure what time period these days that I guess the high schoolers figure out what college they're going to. Have you figured out what college you will be attending after high school?
So I actually start applying in 9 days.
Okay.
So yes. So August 1st is when the application's open, and so I'm hoping UT Austin, because it would be the best. It's one of the best research schools in the country. And I feel like my overall, like pertaining to my research, it would be the best option. And also like the resource, it just joined the SEC, and the SEC, there's $8.8 billion in research every single year. Awesome. And so like between all the schools, so being able to and being a school that does that much research and has been doing that much with tech. They just did something on the electrical side where they are building a new semiconductors lab at the engineering building. So like things like that, with like UT Austin, like Carnegie Mellons of the world, like those big universities who make so much research are my goals right now.
Got you. So then I guess maybe going back to the product and just kind of the process of going through, hey, I have this thing that I'm kind of developing and I'm doing research on that I'm kind of putting together, then to get the actual patent application filed and have it go patent pending. What would you say was because again, we all know that this stuff is not like a linear process that just kind of is a continual incline, but it's almost like a sine wave that have your ups and downs with it all. So what would you say, maybe number one, was your biggest challenge kind of going through this process, but then also what would you say your biggest breakthrough was as far as kind of going through the process? And that may be kind of the two different heads of the same coin, if you will. But what would you say was your biggest breakthrough as well as challenge kind of going through this process?
The patent and the just making of it, or
everything that you have done up until this point, whether it's filing an application, seeing an attorney, kind of getting the data that you need for the research, putting together the actual having that eureka moment of, okay, this thing works and this thing is kind of detecting at a high level, high accuracy rate, kind of do that whole process. What would you say was essentially the biggest up and the biggest down?
Okay, so my biggest ups were probably just the like in the making, like being able to like when you because you're coding it right, and you're seeing okay, so like will this work? You're running because when you click run, if you like, so one thing on Colab I want to mention is that if it doesn't like if there are too many iterations, if you overdid it, it will converge and then it will just shut down the like it will just like. Well, it won't shut. It will just shut down the iterations for that one. So then you're seeing it, and then you can't see the final result. So like I had that happen a few times, and that was my biggest low. But my biggest high from that was seeing when I got to 278 plots, and running it, and then once it finished running, I saw 98.81% accuracy, and like my goal was above 98% because I knew it's very hard to get to 100%. Yeah, but if you're getting above 98. That would still show high enough, and that's way higher than anyone else's work to this point. And so once I saw 98.81, that's probably the biggest high of my research overall. And then the biggest low was I have two of the same level, one on the patent side, one on the actual this on the making side. So the making side, it was finding data sets. It took so long because like people have done pneumonia detection before, not as high, not as well as me, but like when you're finding data sets, it's hard because I'm not going through an actual hospital. I'm trying to just find online, like the one with the most amount of data points. And so having to do that and then implement so many different pieces of data and trying to see which two work the best, or like which one works like not so well and then which one works well, but like for a reason, which is like one of the data sets at 2,000 data points versus 5,000 in the other one. I was trying to find something that showed that difference so I can like highlight that, and that was a hard process. But then in the patent process, the same like level of difficulty was definitely the claims, because it was like, because my goal, I'm kind of like nitpicky. I'm really nitpicky with like everything. Like I try to be a perfectionist. So we're writing a claim and then trying to see how can you make this the best version possible, and like rewriting like so many different times. Because they told me the format you needed in, and then I started, and I just made like my own draft at first, and then they pretty much just finished it off. Yep. It was hard because like I had to, like in caps, I had to highlight this invention, which meant so much to me. Yep. But I had the pressure of like, if I don't highlight it well enough, then I just can't take this next step, because patents aren't like automatic things. They take a lot of hard work. So
yeah, for sure.
That was just the scariest thing for me, those two things.
Nice. No, yeah, and I was going to say, so seems like maybe you kind of took a stab at writing the claims yourself, and then maybe the attorney kind of brushed them up, or...
So I wanted to, so this is actually before everything, like patent-wise. So before I met with the guy, with the attorney, I wanted to make my own claims. And I had searched up on his website. He had his own little format that he said you can follow. And so I wanted to make my own like set of things that he can take from, just to make the attorney's life easier, maybe cut down the price a tiny bit. And so that was like my main goal. And so the problem was that I was too focused in the moment on like making claims when I didn't know actually like the specifics of the claims that maybe that you would know, or that he would know from experience. Yep. And I got too focused on that part beforehand. So then it took more time. I took like maybe like a couple days more just working on it than before sending it to him than actually I wanted it to. And as well, it pushes more pressure on me, even though he would have just like, even if I didn't do that, he like you or him, like as the attorney, you would have just made it already. You would have just made your own set of claims, which I didn't know. Also, like when I started doing it, I thought that I would have to actually write it, that he would just fix it up a tiny bit. So then, yeah, that was like the overall, just like.
I mean, I guess it was good, kind of
practice. Yeah.
Well, yeah, practice for you on your end. But typically the attorney, in a lot of cases, they kind of draft the whole application and they'll give it to you to say, okay, just kind of review it, make sure it's accurate, make sure kind of it says what it needs to say, and then it may be some back and forth between the attorney and the inventor. But typically, the attorney would do the whole thing. So that's interesting and good that you got the practice. I would imagine that kind of where you are at now, it'll be more patents down the line that you will file for, especially with kind of doing the research in college and kind of building the business. It seems like you are, a tinkerer. So, I would imagine that it'll be a lot of kind of more opportunities for you going down the line to, have all this knowledge that you got this time around kind of come back up. So no, that's actually pretty cool. So then I guess as the last two questions that I have for you, as we kind of look to wrap up here, number one, what advice would you give to aspiring entrepreneurs? Because again, a lot of people talk about how they just not enough time or not creative enough or whatever the case may be, but you being a high schooler and doing all the things that you did or are doing currently, we talked about earlier, Eagle Scout, nonprofit instructor, Taekwondo instructor, math instructor, as well as kind of an inventor. Now we can add to that resume. What aspiring advice would you give to entrepreneurs who are maybe on the fence about things and kind of to get them over that line and say, hey, kind of go in and this is what you maybe need to do, but this is some aspiring advice or some advice that you will give to somebody who is aspiring to be an entrepreneur or an inventor such as yourself?
So my number one piece of advice is I'm trying to say something that's not like obvious, but this is just the number one thing you just have to do. It's just researching and starting the process. That is it. Because I didn't know anything about this. I just had a dream about it one day and started watching a TV show and found it. So my process probably will be different than yours, but it would be in your best interest if you want to become an inventor, if you want to become an entrepreneur, just to one, surround yourself with people who will help you there. So finding an attorney, finding people who actually have the experience, possibly Mr. Spears here. Finding people who have experience in the area, talking with them at first. And then if they can be of service to you, that is also great. But then also just starting on your own to see what are the steps you need. So if you want to do a patent, okay, we highlighted today, okay, so what is a prior art search? What are these different things that your attorney and you will be writing up? What do you need to have ready with your invention and to what scale? So the only thing you can really do, because everyone's experience is different, it's just starting the process and then getting to and then just researching what to do next. Because online, everyone has done everything. Everyone's been an entrepreneur, inventing. There are YouTube videos talking about every single step you need to take, and step by step, you watch those, you search those up, you'll be good.
Okay. Nice. And then I guess the last thing I have is, how can people just follow you? I'm not sure if you have a social media presence. If you don't have a social media presence, I know, again, just kind of being in high school, I know at least when I was in high school, social media wasn't a thing, but obviously that was some time ago. So can people follow you, whether it's on the social media platforms, or how can people kind of keep up with what you're doing, not only with your AI detection method, but just kind of other things that you come up with along the way?
Yes. So I'll say my LinkedIn first. My LinkedIn is Prithvi Krishnan. Same way it's going to be spelled in the title. And so you can search up there. My Instagram is prithvi.krishnan17, no spaces. And so that's my Instagram. My email, if you want to get in touch with me that way, it's prithvisk2023@gmail.com.
Okay.
And so, yeah, if you have any questions about how to start, if you want to give me advice, that's also great. Yeah, that's my those.
And then I know what was after the LinkedIn? I want to make sure I write it down so that I can include it.
So the Instagram, Prithvi.Krishnan17. And then I'll let you write that down.
Prithvi.Krishnan17.
Yes. And then my email is Prithvi sk2023@gmail.com.
Okay.
And there are no spaces whatsoever.
Yep. So once the interview comes out, I will put that information down so that people can reach out to you if they, like you said, if they have advice for you, or if they're looking to, just kind of pick your brain on some things. Definitely appreciate the time here today, audience. Again, you're never too young to start something. So even if you're in high school watching this, but even if you're kind of older watching this, hey, this is something that, especially IP entrepreneurship, just kind of creation and being able to protect the creation. That's kind of what I'm about at this point, regardless whether that's copyrights, trademarks. In this case, it's a patent. But just whatever you create, hey, look to protect it. And Prithvi, he talked about a lot today, but I think it was good for us to kind of maybe be able to see that, and again, it being a refresher as somebody kind of being younger and kind of giving us that kind of fresher perspective as he see it, as opposed to someone who's kind of been through the process time and time again. So hopefully you guys got something out of it, audience, and until next time, take care.